Hey, this is Ari. Welcome back to the Energy Blueprint podcast. I am very excited to share today's guest with you. He's somebody who I have an enormous amount of respect for and somebody I've been meaning to interview for a very long time. So I'm glad that it finally happened. His name is Dr. Gerald Pollack, and he has a PhD in biomedical engineering. He's a professor of bioengineering at the University of Washington, and he is also founding editor-in-chief of the journal Water, convener of the annual conference on the physics, chemistry, and biology of water. And he's the executive director of the Institute for Venture Science. His interests have ranged broadly from biological motion and cell biology to the interaction of biological surfaces with aqueous solutions like water, for example. His 1990 book, Muscles and Molecules, Uncovering the Principles of Biological Motion, won an Excellence Award from the Society for Technical Communication. His 2001 book, Cells, Gels, and the Engines of Life, and his newest book, The Fourth Phase of Water, Beyond Solid, Liquid, and Vapor, won that society's Distinguished Award, their highest distinction. The latter book went on to receive the World Summit Excellence Award, and he's also included in the 2019 listing, magazine, as one of the world's 100 most inspiring people. An all-around brilliant guy, and I'm very excited to share this conversation with you all around the importance of water in our physiology, the very much neglected importance of water in our physiology, and a discussion around a lot of the both known aspects of water in our physiology and the potentials of how water may play a role in many aspects of our physiology and our health and our risk of various diseases and our energy levels that has largely been neglected in conventional discussions of physiology. So I hope you enjoy this very informative and very cutting edge talk with Dr. Gerald Pollack. So welcome to the show, Jerry. Such a pleasure to have you.
Thank you for having me. I'm delighted, thrilled.
Wonderful.
Actually.
So tell our listeners, I should say, since I'm very familiar with your work, I followed you for many years, how you first started getting into this field of researching water.
Well, we had been researching muscles, looking for the molecular mechanism of contraction, and there were some theories out there, and a prevailing theory by the distinguished and famous Nobel laureate Sir Andrew Huxley, especially. But all the theories made an implicit presumption that the muscle proteins are acting in a vacuum. They never took account of water, and after some time, this seemed weird to me, because muscle, like other tissues, typically is 2/3 water by volume. And if you translate that into the fraction of molecules that are water molecules, it's impressive, because water molecules are small, and to make up that 2/3 volume, you need a lot of them. And the calculation shows that it's more than 99%. So in other words, if you line up all the molecules in the muscle, more than 99 out of 100 are water molecules. And to make the presumption that water was irrelevant, that 99% of the molecules don't do anything, eventually seemed to me to be beyond reason. How could it be that 99 out of 100 molecules don't do anything? It's like, sitting in the bathtub in the water, and that's the presumption that's made in all the textbooks. So I had occasion to go to a conference at which I met scientist Gilbert Ling, who had been studying water, biological water, for many years. And by that time, he'd written, I think, 5 books. And by the time he passed a couple of years ago, it was up to 7, most of them dealing with the water in biology. And he, at that conference, I heard him present, and I heard a dozen other people who were invited who had evidence to support his point of view that in biology, the water was actually different from liquid water. And by the way, you can, or anybody can tell by themselves. All they need to do is cut themselves. If it were liquid water, you cut yourself, the water would come pouring out as in the same way that water comes pouring out from a broken pipe. But of course it doesn't happen. And so the water is gel-like. It sticks inside the cell, and this is a sign that the water is different. And that's where we got our start. So if that, I don't want to go on and on because I know you have a lot of other questions, but it was a transition from muscle contraction, which seemed the water seemed irrelevant, to thinking that water is central. That's how we got started.
Yeah, I think historically the way that it's been conceptualized in physiology, and I can think back to my many physiology courses I've taken over the years, there's no discussion of water other than, kind of this implied paradigm of understanding the cells as sort of a bag of water, and the water is really only there to dilute the concentration of things like potassium and calcium and sodium and so on to the appropriate concentration. So like you need to have the appropriate balance of water to these various ions that are present, but it's never really discussed in physiology that the water molecules themselves might be doing something important beyond that. So can you talk about what exactly is the significance of this sort of gel-like property of water at the physiological level?
I can, and this is best illustrated in a book that I wrote 20 years ago. It's called Cells, Gels, and the Engines of Life, and the book was primarily designed to translate Gilbert Ling's ideas into a language that is moderately understandable to ordinary people like myself. Gilbert Ling is difficult to penetrate. He'd sit down at the word processor, and before that, the typewriter, he'd bat something out, send it to the publisher, and that's it. And, to produce something intelligible, you need to edit, re-edit, edit again, get some feedback, et cetera, et cetera. So I tried to do that, and that was the first half of the book, is explaining Gilbert Ling and his ideas, which, by the way, in later experiments we found is not quite the way Gilbert presented it, but I'll get to that later. The second half of the book provides evidence to answer the question that you asked: what exactly does the water do? And so the evidence suggests the following. When the cell, doesn't matter what kind of cell, whatever, if it's in the quiescent state and not doing anything, well, for example, like a muscle cell that's not contracting, or a secretory cell that's not secreting, all the water is in this special state, which I'll talk about in a few minutes, an ordered state, something like what Gilbert Ling was talking about, the ordered state. Then when it transitions into action, by action I mean the muscle cell contracts, the secretory cell secretes, the nerve cell conducts, it doesn't matter what. It involves a transition not only of the proteins, but also of the water inside the cell. So it's the proteins in the water together undergo a change, and the water, it's called a phase change. And the water undergoes the change from the ordered state to ordinary liquid water, and then back again after the activity is finished. So the water undergoes a cyclic change from one state, the ordered state that we call the fourth phase of water, or easy water, into ordinary water, and then back again. So if we're right, and a lot of evidence was adduced to support this point of view, then the water plays a central role, absolutely central role in everything that the cell does. It doesn't just sit there to fill space.
Mm-hmm. It's been many years since I've looked at Gilbert Ling's work, but what I recall was that he did some mathematical calculations around the amount of energy that would be required to maintain ion gradients. So for listeners who may not have a background in physiology, there are certain ions that are present inside of the cell and outside of the cells, and in certain concentrations. Certain ions may be high inside the cell and low outside, or vice versa. And we have certain pumps at the cell membranes that are designed to maintain those ion gradients. So like the most famous one is the sodium potassium ATPase pump. The ATPase part is that it requires ATP, which is cellular energy produced by our mitochondria. So it turns out, I think Gilbert Ling said something to the effect that, when you analyze all of these different ions, sodium and potassium and calcium and all the others that are needed, that our cells have to maintain these appropriate ion gradients, differences between inside and outside the cell, it would cost some ungodly amount of cellular energy, ATP, to maintain those gradients all the time. And this would be consuming such a huge portion of our total energy if it was such an ATP intensive process. And he said something to the effect of, basically, it can't all be ATP dependent. It has to be largely dependent on the properties of the water itself. Is that accurate? Or maybe you can
Well, yeah, I mean, that calculation was, as I recall, for the sodium potassium pump, I think it was 30 times or something like that, what the cell could possibly muster, just to run that pump. But now there are hundreds of putative pumps in the membrane, if not thousands. A student of mine went into that field, and I asked the question, and I think it was a couple of thousands that now are said to exist. So the amount of energy that's required is I mean, astronomical compared to what the cell could possibly produce, which means that it's got to be wrong. Something is fundamentally wrong. And I can add to that discussion, because I agree with it. There is some absurdity to it, even though it's widely accepted and appears in so many textbooks. And that is, we did a lot of experiments sticking electrodes into cells. And if you stick an electrode into a typical cell, you record a potential difference between the inside and the outside of -60, -70, -80 millivolts, and that seems to be the case in healthy cells. And the surprise, and this is said to be due to the membrane pumps largely, and also the channels in the membrane, ion-specific channels. But the funny thing is that if you stick the same electrode, instead of sticking it into the cell, if you stick it into a gel with no membrane, and obviously no pumps or channels or anything in the membrane, because there's no membrane, you get the same result. Same result. So if you wish to attribute that electrical potential to some membrane features, then you need to explain why you get the same result if you have no membrane. Mm-hmm. It's just it's possible that there are two mechanisms that give rise to the same result, but most unlikely. Mm-hmm. And we have a different explanation for a very simple explanation. Maybe I'm just getting ahead of myself, but the kind of water that Gilbert Ling was talking about, he's called it structured water. And his idea was that the molecules are like dipoles, plus at one end and minus at the other end, and they can stack, they can line up with certain order. We found that that's not exactly true. There is order, just exactly as Gilbert Ling said, but the order is different, and I can talk about it if you ask me. But just one feature is that water has a negative charge. It's not neutral anymore. And there's a change that occurs when the water meets certain surfaces, and the water transforms into what we call fourth phase or easy, and Gilbert would say structured, same thing, has negative charge. So because this water fills your cells and has negative charge, it doesn't take a rocket scientist to figure out that, if you got a bag of some sort filled with stuff that's negatively charged, you stick the electrode in, you're going to get a negative electrical potential. So I think that this is the negative electrical potential in the cell, which started all of this stuff, arises not from pumps or channels or anything like that, but from the fact that the water that's inside itself has negative charge. Simple explanation. Okay. And the gel too, same thing with the gel.
Okay. Now, connecting everything that you've talked about so far, let's connect it to health. So what do these properties of water and this negatively charged water, fourth phase, easy water, what do they have to do with allowing the cell to function properly? And like, how does that translate into health?
Great question. I think it's straightforward. So as I said before, because the activity of the cell involves a transition from structured, easy, fourth phase water to ordinary water and back again, if the cell doesn't have enough of this special organized ordered water, then it's not going to function properly because it's a central requirement of what the cell needs. And what that translates into is that you look awfully healthy, but to maintain the health, you need to make sure that that the cell is filled with this kind of water. Otherwise, one cell or another tissue or whatever is not going to be functioning properly. So the central, how should I say, central dogma, if you will. I hate to use the word dogma because it sounds awfully dogmatic, but the central principle is you must make sure that your body is filled with this kind of water. And so that translates into a few simple expedients that I can tell you about if you ask me, that you can do to make sure that you're maintaining a proper quantity of easy water throughout your body.
Okay. I want to get there in a second. I want to address, it's funny, since your work came out many years ago in your book, The Fourth Phase of Water, I was immediately very impressed and enamored with it. And I saw, it was very clear to me that the relevance of this to physiology. But I have a couple of, I would say, more conventional medicine-minded friends who are not really proponents with natural health and, not part of that movement. And some are quite smart, quite scientifically literate and well-versed in physiology. And a couple of them were very skeptical of your work and, kind of said things like, well, yeah, okay, so you can take these plastic tubes. I forget the material, the
Nafion,
that's right. Nafion tubes, and you put them in water, and it's this hydrophilic surface, and it generates this easy water and this flow of water and all these things. And yeah, you can do those experiments, but this doesn't have any relevance to physiology. So I'm curious what you would say to those kinds of skeptics of your work.
Well, I guess I would need to ask what's their rationale for suggesting that it has nothing to do with physiology. If that's their point, I I would request more specifics on, why they think that's the case.
Yeah, it's basically like, well, this Nafion material is not what our cells are made of. So what's the relevance?
The relevance is that besides Nafion, which we like to use because it's simple and really easy to use, I'd say we've looked at in excess of 50 different substances that do the same thing. Some of them are biological substances, like ghee, for example. So, clarified butter. It produces EZs or fourth phase water extents that are larger than anything that we've seen, almost 1 millimeter. So you take some ghee, put it in the refrigerator to make sure it's fairly solid, put it in water. And then the way we look at exclusion zones is they exclude particles or microspheres that we use. And so it's easy to look at the extent of that zone of exclusion. And we were shocked, just shy of 1 millimeter, which means roughly 1 million molecular layers that we see on a regular basis. So that's one argument. Sure, Nafion has nothing to do with biology, but ghee certainly does. And we've used, as I said, some 50 substances. So that argument, I think is specious.
And how do cell membranes and mitochondrial membranes, organelle membranes fit into this picture?
Well, they fit in.
Or other substances inside of the cell?
Well, other substances, particularly inside the cell, is what I'd focus on. So what's inside the cell? 70%, 60 to 70% are proteins, and another, I think, 25% nucleic acids plus other solids. And the surfaces of these components are mostly hydrophilic surfaces, that is water loving, and those are precisely the kinds of surfaces that build easy water. Mm-hmm. So it means that that inside the cell, these surfaces ordinarily nucleate the growth of easy water. In other words, converting ordinary water to the liquid water to easy water, and the cell is so densely packed. If you look at electron micrographs of the cell is virtually so crowded with solids, really packed. In fact, the average distance between solid surfaces, where there's water in between, average distance is equal to roughly the diameter of 7 water molecules stacked together. That's how close these surfaces are, which means there's not a whole lot of water to structure. You don't need, in order to get all water inside the cell structured, you just need to, the surfaces need to nucleate the growth of a few layers of water molecules. That's all, and then the cell is filled with this stuff. So, I might say another point that's more general about objections. There have been a half dozen or so papers published over the past decade that suggest that there's something wrong, and I responded, published to the first one, which is very extensive, and many of the others follow from that. But there's a tendency in science to want to stick to the status quo. Most of us, we're human beings. We grow up with a series of facts, kind of knowledge, and we feel comfortable in that. If somebody comes along and says, well, wait a second, I'm not sure you're right, because there are a few issues with that. And this is typical. So I remember the story about Lord Kelvin, for example, who is a famous physical chemist, and a couple of 100 years ago, 150 years ago, I forget the exact dates, he famously declared, there were some rumblings about the possibility of airplanes. He said, nothing heavier than air will ever fly. And then a couple of years later came the Wright brothers. so it feels comfortable even for well-known scientists to profess that the status quo is okay. We like it. We feel comfortable, and somebody coming along to challenge that is a problem. And there's another famous quote by Max Planck. He said, because of this sort of resistance, he said, "Science advances one funeral at a time."
Mm-hmm. Yeah.
And the best one, I think, of all is Albert St. Georgi, who was the father of modern biochemistry. What a creative mind this guy had. And of course, he won a Nobel Prize for discovering vitamin C. He had so many ideas, and when he presented his ideas, he said, "The only time I knew I was on to something really significant was when the response was polarized. Some loved it and others hated it." Mm-hmm. So I kind of, take the issue of controversy as something that's expected. Of course, it happens to virtually every finding that challenges the status quo. But we've responded to, at least early on. I specifically, I think the arguments are specious.
Mm-hmm.
So,
okay.
Long
Excellent.
answer to your short question.
Yes, great answer. So let's quickly summarize what easy water is actually doing in the cell to create benefit to cellular function. And then from there, and I know you've touched on that already, let's kind of summarize it. And then from there, I want to ask you about methods to enhance easy water in the cells.
Okay, so I've argued that you need a full complement of easy water because cellular processes depend on that water. So what, it doesn't take a rocket scientist to figure out that if that's true, what you need to do is to make sure to enhance the amount of easy water. And so what can you do? So I've got a half dozen different expedients. So the first one, and I need to add a little backup, fill-in material to make, if this is to make sense. Let me provide that first, because otherwise, and then refresh me if I go astray. Okay, yeah. Because I have a tendency to do that.
You got it.
Yeah. So this kind of water that we're talking about, in order to go from liquid water, which has no particular order to it, the molecules are randomly disposed and bouncing around a fierce number of times per second, or even per femtosecond, doing all that. In order to convert that into something ordered, which characterizes fourth phase water, as I said, not the way Gilbert Ling taught, but a different way, which I could amplify if you ask me, but I can skip it for the moment. To go from chaos to order, you need energy, and it's a general principle as illustrated by your office. Yours looks pretty neat, but in order to
can't take credit for it. I'm in an Airbnb right now. I would like to say that my space is this organized, but it's somebody else.
Okay, so if in your space, if you want to organize it, it takes energy, right? Yeah. You got to put your mind to it, spend 30 minutes piling the papers correctly. It's a general principle to go from chaos to order. You need energy. So where does this energy come from? We found in experiments that it comes from light. In a way, the way plants use light in photosynthesis, but in this case, the light we found in experiments is infrared light. So that means, wavelengths that are not visible to the naked eye, just a wavelength just longer, a little bit longer than the red light, which is the longest wavelength that we can see. Just beyond that, infrared it builds it like gangbusters. We used in our experiments an LED, light emitting diode, with very weak infrared light, and we could build we can increase the size by a factor of 10 times how powerful it is. So just a little bit of infrared light is enough to do it. And so to build water in your body, infrared light is useful. And so where does infrared light come from? Well, in your Airbnb, if we turn off all the lights and I came with my infrared camera, which is just like any other camera, except the sensor is sensitive to infrared rather than visible light. I'd get a perfect image of you, your beard, the little gray spots on the sides, your microphone, and the picture on the wall, et cetera, et cetera. So no problem. It's all around us. And also, since infrared is roughly equivalent, not exactly the same as heat, the metabolism that you're generating inside your body is also giving rise to that. So there's plenty of infrared both outside and inside when in terms of you, and this is necessary. This kind of energy. So one way, long introduction, is walk out in the sun. And where I live in Seattle, in the wintertime, ain't much sun. Lots of clouds in the winter. It's kind of gray, and some people get depressed. However, you walk out in the sun and feel good. The sun will just peep through a hole in the clouds, and suddenly you feel better. And this is pretty universal. And of course, the explanation is it must be some psychological effect, and that's reasonable and probable. But there's another, that is the infrared from the sun. Roughly half of the radiation from the sun is in the infrared wavelength. That's why it feels warm. So that penetrates your skull, for example, into your brain, and it should, if theory is right, it should build easy water in the neurons in your brain, and you return to your default situation, which is feeling good instead of depressed. We don't get born feeling depressed. So that's the first thing you can do, is go out in the sun. Another thing.
Actually, before we go on, just maybe a quick digression into that first one. I don't know if you know, I've authored the most prominent book on the subject of near infrared and red light therapy.
I was not aware. Sorry.
Yeah, no worries. So it's called The Ultimate Guide to Red and Near Infrared Light Therapy, and so I have quite a bit of expertise in this topic, and I've spent a lot of time thinking about it, and also thinking about it in conjunction with your work. And given what you said about sort of objects in our house emitting some degree of infrared, I think it's interesting to think about modern lifestyles and exposure to infrared compared to ancestral lifestyles. So ancestral lifestyles, to your point, we would have spent a lot more time being exposed to sunlight, but also, if you, for example, if I go outside and I walk on a trail and I walk barefoot, or if I go to the beach and I walk barefoot, there's a huge amount of infrared that I'm soaking up through my feet, not only from the sun, but also I think the outdoor environment of walking on that sand or that dirt, and on being exposed to, even not necessarily barefoot, but you're being exposed with probably, I would imagine, many orders of magnitude greater levels of infrared than you get in typical indoor environments. So I wonder if you have any thoughts on sort of the modern lifestyle, people living mostly indoors versus outdoor with regards to daily exposure to infrared.
Well, I would just second what you've been talking about. Sure, any source, particularly a persistent source of infrared, should be good for you. And perhaps in that book, you also were dealing with some clinical effects of infrared.
Yeah.
And I've heard from various. For example, I met a guy. in Germany who is a practitioner, and he was dealing with women who have cancer somehow in some region of their face, and they don't want to have surgery for obvious reasons. And they go to him, and he said he treated it with infrared energy, and it was the impact was amazing. The cancer just basically disappeared as a consequence of that infrared energy. And again, it would, my take on that, this is just my opinion, is that these cancer cells that are dividing in ways that they shouldn't be dividing, they go back to normal. And the proteins in the water, especially inside the cell, returns easy. Water gets built, and the cell is then back to its normal state. And there were some studies of to support this point of view. There were some studies of cancer cells years and years ago, and the experimenters stuck microelectrodes into the cancer cells. Instead of having an electrical potential on the order of 60, 70, 80 millivolts, they had 10, minus 10 or minus 15 millivolts. Translation, if the electrical potential arises from the water, from the EZ water, fourth phase water, there's not enough of it. And that, to me, makes total sense, because the cell is kind of in the on position or activated position, and it keeps dividing. And so all of this is sensible. But let me return to walking on the beach barefoot. What you say makes total sense. Over and above that, there's another issue that I think might be equally fundamental, and that is you're connecting yourself electrically to the earth. So what is that? Why is that significant? So you're walking barefoot on the sand near the water, or there's some moisture, conductivity is high, and what I learned only maybe a dozen years ago is that the earth is not neutral, it's negatively charged. Of course, you know that, but I didn't know that. I was actually shocked, so to speak, because I started my career studying electrical engineering, and no professor ever told me that when you stick the plug into the receptacle, that third prong, the round one, is connecting to anything other than zero electrical potential. But my Russian friend who was working in my laboratory started talking to me about the Earth's electric field. And I said, Andre, you're talking about magnetic field. I never heard of electric field. Electric field of the Earth. He said, well, of course, don't you know that the Earth is negatively charged and the ionosphere is positively charged? And it's like a capacitor. We have plus here and minus, and you get an electric field between the two, and the Earth is negatively charged.
And sometimes you get lightning strikes.
Sometimes you get lightning strikes. Absolutely. Yeah. So I'm talking that has to do with the clouds, is maybe slightly different issue. I can talk about that also, because but let me not
don't digress.
Digress. I have a tendency to digress too much. Okay, so he said in Russia, there must be something really weird about your educational system here, because in Russia, every middle school student knows that the Earth is negatively charged. So I had to admit that maybe our educational system was not the best. But I went home scratching my head, and then next morning, one of my students comes with the famous series of lectures, a 3-volume set by the great physicist Richard Feynman, which is consumed by probably almost every graduate student in physics, because it's got humor, it's clear, et cetera, et cetera. So he opened it to volume 2, chapter 9, and there in volume 2, chapter 9, was evidence that the Earth is negatively charged. So, the evidence is clear. It's just that we don't learn about it. So what am I getting to? When you connect yourself electrically to the Earth is negatively charged. If you're missing some of this, shall we say, negatively charged, easy fourth phase water, the electrons are able to flow from the Earth then into your body, into specifically those regions of the body which are not as negatively charged as they should be. So the electrons come pouring in, and in the lab, we found that electrons build easy water. You have a container of water, and you stick 2 electrodes in, and if you look what happens next to the negative electrode, you can see easy water building next when you pass electrons in. So negative charge builds easy water, which has negative charge. So it doesn't make sense. And so I would argue that another possibility, you're walking on the beach scenario, if you're connecting electrically to the Earth, which you can do by walking barefoot on the sand, especially near the water, or you could stick yourself in a mud bath, or even jump into the ocean. You feel good afterward, and I think one candidate to explain why you feel good is what I suggested, that the electrons from the Earth go into your body and build easy water.
So there's these 2 mechanisms then of how sort of being outdoors can potentially build easy water, both the infrared energy and the picking up electrons from the Earth if you're walking barefoot in the appropriate environment, or swimming in the ocean.
Yes. Absolutely. Okay. Yeah.
Okay. So as far as other strategies to increase easy water in our cells, I have to ask you this. I know you have a list. I'm sorry to interrupt, but I want to insert this because I want to make sure we cover it. One very controversial area is the drinking of water that is supposed to be structured water, or is water of this special property, or is easy water, or something like that. And I know that there are many people that I know that are sort of familiar with this topic who have poo-pooed that idea, who have said, no, there's no possible way this could be relevant. This is not the way to build easy water in our cells, because once that water hits our stomach acid, it's going to go through some chemical breakdown where the structuredness or the easy water aspect will be destroyed anyway. But the way to build that easy water is through like the methods we just described, through exposing your body to infrared or picking up electrons from the Earth and such, but not necessarily drinking external easy water. What are your thoughts on that area?
Well, I mean, this idea has been brought up in the past, that the stomach acid will neutralize, and the easy water has negative charge, and the stomach acid is at low pH. Excuse me. Sorry.
Bless you.
Thank you. And it's going to neutralize it. But what sometimes they fail to take into account is the volume of each one. Just a little bit of stomach acid generally in our stomach. So if you drink, let's say a glass of water, then not just a sip that I took, but a glass of water, and then the volume of that water completely overwhelms the small amount of stomach acid. And so there will be some, obviously, when the two combine, there will be some neutralization of the negative charge that water has, the easy water, but it's not much. And we did experiments to check on pH to see what effect it has. And we found that we measure the amount of EZ as a function of pH. And you start with a neutral pH. And we found that going from neutral pH of 7 to all the way up to 9 or down to 5, essentially no impact at all on the amount of EZ. If you go to lower pH than that or higher, then it begins, the amount begins to diminish. So moderate changes or modest changes of pH because of stomach acid should have only a minor effect. So if you drink a sip of water, the argument may be correct, but if you drink a glass of water, at least in theory, it should not be correct.
Oh, that's very interesting. I hadn't heard that counter argument. So given that, it sounds like you do think that there is relevance to providing external easy water as potentially a method to help build up internal easy water.
And I would stress the word potential because it needs to be checked.
Right.
And it wouldn't be so difficult to check. I think the way to check is to do clinical experiments, in terms of efficacy. Take a bunch of patients with some particular issue, let's say stomach cancer or something, and offer a fraction of them one type of water, and another fraction of them a different type, and so on, a half dozen or more different waters, and with enough statistics, you can actually judge the impact of the different kinds of water on the outcome. That would be the way to do it. But, unfortunately, getting the NIH, National Institutes of Health, who would theoretically fund these kinds of studies, they practically never heard the word water.
I think they're too busy funding gain of function research.
Well, we can discuss the areas that they do fund, but they're not, shall we say, particularly flexible. Actually, some years ago, I proposed that you need to the NIH, and is like a lead balloon that didn't go anywhere. Water? What are you talking about? Water. It didn't even make the review desk because it seemed so uninteresting. For me, the NIH is doing so many clinical studies together with the pharmaceutical companies to look at the latest drug. They spend hundreds of millions of dollars doing this. And I think for $5 million or $10 million, a decent study can be done to answer the question that you raised, whether, if you drink water that contains EZ, is it really better for your health? I would speculate the answer is yes, but it's just a speculation until it's tested. It's really important to test that. I get asked by so many people, which water should I drink? And I tell them, I don't know.
Got it. Maybe what you need to do is have some pharmaceutical companies patent the easy water so that they can make money off of it, and then you can attract some funding to that question.
Actually, funding is an issue. You didn't ask me, but we've been in the past funded both by NIH and more recently by a man of some means who loves our work and has wanted to fund it indefinitely and very generously, but he suddenly ran into some financial difficulties and he's had to stop. So we're kind of desperate, actually looking for money, because unless we can replace the money that he had been supplying, we're out of business. And
where can people go to donate money to your work?
Well, if it's a modest amount, our website, pollacklab.org, it's easy, and there's a donate button. If it's something more substantial, which is, what we're looking for, because it takes a lot to run a laboratory, just email me and I'd be delighted to discuss with anybody who would be interested. It's a simple email address, GHP, my initials, GHP at UW, that's for University of Washington, uw.edu. So GHP at uw.edu. And if you can't, it's all over the internet. I'm not invisible.
Perfect. Yeah, I hope that many listeners will donate to you after listening to this podcast. I certainly think your work is a profound contribution to the field of understanding human health. So,
Well, thank you so much.
Yes.
Appreciate anybody who has the means and is interested. It would mean a lot to us.
Yeah, and I'm going to be making a donation to you personally as well. So I hope
Thank
listeners
you.
will do the same.
Wow. Many thanks. Okay.
Yes. So thank you for your work. So I want to get back to sort of other strategies. So if the drinking of external water is not necessarily a good approach, I know friends of mine who are sort of in the biohacking space, I've seen them, making these concoctions and shining red light on the water before they drink it, and, infrared light and things like that. It sounds like that's possible, but very speculative. So we know that infrared and probably grounding or earthing is playing a role, but are there other strategies that relate to building up EZ water in our cells?
There are. One of them is the sauna, right? Or as the Finns say, the sauna. And I mean, it's whether it's dry or moist, it's hot. And the heat is essentially the same as, not exactly the same, but the distinction is subtle, is infrared energy. So you're exposing yourself to huge amounts of infrared energy. And for most of us, you go in and you come out. When you come out, you feel better than before you enter. And I think the explanation is, again, straightforward. It's just exposing yourself to that massive amount of infrared energy will build EZ water, and EZ water will bring or restore function back from dysfunction to function. So if you go in with a muscle ache, you may come out without the muscle ache. And if you go in feeling depressed, you may come out feeling happier, et cetera, et cetera. So this is, I think, a third means. Another one, or fourth, I don't know where we are. Another one is there's certain substances that have been known for many years to be conducive to good health, starting from way back from Ayurvedic times, 5,000 years ago, or even older. And we wondered about these substances, like turmeric, for example. A lot of people take turmeric if they've got one problem or another problem. Yeah, let's take turmeric and see if it gets better. And seem to be two hypotheses. One hypothesis is that we have turmeric receptors all over our body. And if you eat turmeric, the receptors are turned on, and somehow that improves a function. Another one is it has one target, and that target somehow distributes itself throughout the body, and that would be water, or particularly EZ water, because you need EZ water for proper function. So we're wondering to test whether some of these substances build EZ water, simple and direct. And we published a couple of papers on that, and it indeed is exactly the case. So it's not just turmeric, but I mentioned ghee and basil, holy basil, so to speak, and various other substances that have been known for millennia to be good for health. They all build EZ water over a fairly wide concentration range that would be relevant to what we might experience inside our bodies. So simple expedient for good health is to take some of these substances. It basically confirms what people from ancient cultures have known for so long, and it provides a possible simple mechanism to do that. Another one is to do juicing, and about juicing, but I don't know if all of your listeners know. So you go to your backyard, you take some fresh plants and or the leaves of fresh plants, and you squeeze them to death and squeeze the liquid out and drink it. And so what is that liquid? Well, the liquid is the basically intracellular water that exists inside the plant cells. And that water is just filled with EZ water. I mean, it's a huge amount. What you drink has a huge concentration of EZ water to it. And so by drinking that, you're basically bypassing the requirement of your own body to convert the water that you drink into EZ water. You just drink it. And you know, and I've heard from various health practitioners that they give this advice to their patients, no matter what, almost no matter what they come in with, and the patient will go home and come back a few months later and report that whatever the issue was, they've improved markedly, and they've also lost weight in the process. I don't know the reason for that, but that makes sense to me, and that would be another expedient. Maybe a little more complicated than some, because you have to go to your backyard, but you know, you get some exercise in so doing.
So that relates to the previous question of drinking the external EZ water. You think so that the most plausible way that could be a reality is in the context of vegetable juice primarily, or maybe also fruit juice, I would imagine, though maybe the sugar content sort of could counterbalance that.
No, I'm not sure, but yeah, maybe. I haven't thought about that issue about the sugar content, but yeah, I mean, basically, you can actually eat the whole plant and get the same result, but you get filled up so quickly from all the solids that there's no need for that. And so the idea is just squeezing out all the juice and just drink the juice and get an equal benefit from that. It's simple. So those are, I think well, I guess I should mention, this one is not so simple, but hyperbaric oxygen therapy. So it was originally used for wounds that wouldn't heal. For example, wounds in battle and soldiers, and it came to pass that if the soldier enters into one of these chambers in which high oxygen and high pressure, the wounds get healed. And since then, it has turned out to be clear that there are many syndromes that improve from hyperbaric oxygen therapy. So again, you know, we're thinking, what could be the reason why so many different pathologies can be reversed from hyperbaric oxygen therapy? And we wondered, is it possible that the high oxygen and or the high pressure builds EZ water? We tested it, we confirmed it. Both of them build EZ water. So I think, again, this is a simple, well, it's not so simple, because you need to go to a clinic that has one of these hyperbaric oxygen chambers, or have one of your own. It wouldn't surprise me if an increasing number of people decide to purchase one and keep it at home, because it's apparently good for so many different issues, and we think we understand why. It's just a buildup of EZ water.
Yeah, very interesting. The science on hyperbaric is quite rich. I've done a previous podcast on it with a friend of mine who runs a clinic for hyperbaric named Dr. Scott Scher. And you know, I know that also even high-level athletes, it's used in the context of traumatic brain injuries. Frequently, it's used also by high-level athletes to enhance recovery. And there was one documentary I saw on World's Strongest Men competitors where Eddie Hall, who was a former World's Strongest Man champion, was saying that it speeds his recovery time. You know, it cuts his recovery time in half. You know, if it normally takes him 2 days to recover from a training session, now it only takes one, something to that effect, or it even allows him to train 2 times in the same day. So, you know, it seems hyperbaric's quite profound. I'm curious if there's anything about cold, like ice baths and cold water baths have become popular these days. And I believe I remember reading in your book or somewhere hearing you talk about ice and easy water. Is there some relationship with cold as well?
Yeah. So if you accept the principle that infrared energy is critical for the buildup of easy water, and also that the buildup of easy water is critical for health, then see, if you bathe yourself in ice, as demonstrated, the infrared energy that is the core of your body will get transmitted through your tissues out to the ice, in the same way that the Earth in the evening radiates infrared energy to the cosmos, and thereby cools. See, same principle, I think, would apply. So you generate the infrared energy from the core, it passes through all the relevant tissues and then out to the
So
core.
would that reduce easy water in the cells?
No, that actually increases easy water, because in theory, because the infrared energy is passing through the tissues
Okay.
on its way out, you see. And
Yeah.
so some of that infrared energy is absorbed by the tissue before it comes out.
Interesting. So what's, in that way of thinking, what's the origin, the source of that infrared energy?
Well, the heat that's generated because of metabolism
Okay.
inside your body. Now, if you keep yourself immersed for a very long time, I suppose, there could be negative consequences, but for a moderate amount of time, I think that's a possible explanation of what's going on. See, your tissues don't care which direction the energy is coming from, whether it comes from outside or whether it's coming from inside. In this case, it's certainly not coming from outside, because the ice is not generating a whole lot of infrared energy. It's very low, but your metabolism is still generating it. And so it passes from your core out through all your tissues out to the ice bath. And in so doing, builds easy water in the tissues.
Very, very interesting. And, this also makes me think of the practice in some Scandinavian countries of alternating between cold water baths and saunas, and perhaps you're amplifying the effect by doing two methods of building the easy water.
Well, they know what they're doing in Scandinavia.
Yeah, and the literature is obviously robust around sauna use and disease prevention, cardiovascular risk, neurological disease risk, and all-cause mortality risk reduction. So those endpoints are there. It's just a question of, and there's various other mechanisms at play, surely, but it's interesting to consider whether this may be a key mechanism for mediating that effect.
Yeah, absolutely. Yeah.
So are there any other points in this discussion that you feel we may have missed before we wrap up?
Numerous.
Is there anything critically important that you would feel remiss about if you didn't mention?
Yeah, I think easy water is all over. It's not just inside our bodies. I wanted to mention that, because wherever you have water, sitting next to a hydrophilic surface, not every hydrophilic surface, but most of them, and you have infrared energy, which is all over, you're going to have some amount of easy water. And I guess what I'd like to do is to mention my forthcoming book, which deals with, it deals basically with easy water, and particularly the electrical charge of easy water. And in this forthcoming book, and I'm waiting for my son, who's the artist of the fourth phase book. He's fantastic. To finish remodeling his house so he can devote some time to finishing the cover and the illustrations. But it deals with easy water, and with particularly the effects of electrical charge involved with easy water, in explaining so many phenomena in nature that we attribute to other explanations, but we don't really understand them very well. When we scratch beneath the surface, answers become difficult, and the subjects range from what creates wind, what turns the earth every 24 hours, what's the true nature of gravitation, weather. EZ and electrical charge are absolutely critical for weather. There's no, that I could find, no fundamental theory of weather that starts from first principles and builds up. Nothing like that. We really don't understand clouds, evaporation, and all of the common features. To how birds fly and how sailboats can, some kinds of sailboats, ice boats can sail almost directly into the wind. Shouldn't do that, because according to Newton's laws, if the wind is coming at you, you're going to go backwards, not forward. And so I guess I just wanted to mention that that book is on its way and hopefully published in the next 6 months or so.
Wonderful. I guess what's the name of that book?
Well, the main name is Charged.
Cool.
And there's a sub name, and I can't remember exactly what the words are, but something like unexpected features, or the role of, I think the role of electrical charge in our environment, or something to that tune. But the words are nice words that are put together, but I can't remember them exactly. We did a poll, a Google poll, offering 10 different names. And this one, the one that we chose, is the one that was the most popular.
Great.
So I think that's about it. There are many things to talk about, but you said, is there anything really critical that I haven't talked about? And oh yeah, maybe just one more. The EZ is negatively charged. The region beyond is positively charged, because all of this starts from water, which is neutral. And so if you have a region that's negative, you have to have a region that's equally positive. So you got those two regions. And if you stick electrodes in, 2 electrodes, one in the negative, one in the positive, you get electrical energy out of that. So this is actually sun-driven or infrared energy driven electrical energy that can be tapped. And it's just a matter now of building up, because the amount of electrical energy that we're able to obtain now in the laboratory is small, very small, but the principle is proven. And so this is a matter of building up. Yeah, I wanted to mention that. Okay.
Yes, wonderful. Jerry, can I ask you how old you are?
82.
82. Wonderful. I hope you live a lot longer and you can continue to do such amazing work in this field.
Well, thank you. My naturopath promises 120.
Beautiful. Wonderful. So
energetic as when I was 30.
Yeah. Well, I hope to have as highly functional a brain when I'm 82 years old as you do. Well, and I guess to my final question to you is, given that you've had a lot of experience and you've done a lot of research and thought a lot about health related topics, what would you say are your top 2 or 3 recommendations that you want to leave people with as far as staying or becoming healthy?
Well, we need to keep hydrated. This is a problem for me, and my dear physician Dietrich Klinghardt tells me, drink more water.
It's funny, you of all people need to be told. Well, yeah. If even you need to be told that, there's no hope for the rest of us.
I also think there's a future in so-called subtle information that's coming into the water. This is a frontier that I think or a topic that will be a frontier topic in the very near future, because the evidence for this is overwhelming from many different people. It's just that it's rejected resoundingly by people who are more conventional in their thinking. But it's the job of scientists not to reject something because it's not traditional, But if there's enough evidence for it to search for the mechanism to try to understand, and there's no understanding yet, no real understanding of how this works, but it's going to be a subject in the future.
Well, sorry to ask you to go on a digression, but this is actually a topic I meant to ask you about and forgot, but maybe you can touch on briefly. I don't know if you have to go. Sorry if I'm keeping
I can go on briefly.
Okay.
No.
What is some of that evidence, and what is this, this word information, water carrying information? What do these terms mean, and what is the evidence to support it?
What does it mean? And well, what it means is that well, how to put it in different words, is that the water has a capability of well, I don't know how to put it in any way that's different, storing information.
What kind of information?
Subtle information that we don't, the nature of which nobody understands. But let me tell you the evidence for it, because I mean, without going on too long, it ranges from the spiritual to the highly scientific, and the spiritual starts. It actually starts before this, but the famous person is Masaru Emoto, who passed some years ago, and the work is being carried on by his son, Hiro Emoto, and I'm well connected with their group. And what Emoto demonstrated to a broad audience is, he had a container of water, and he put his intention toward the water. If he thought, I love you, or positive thoughts to the water, and they froze the water and looked at the ice crystals that formed, and they were beautiful. On the other hand, if he said to the water, I hate you, or had negative thoughts that he imparted to the water, then the crystals were ugly. And he wrote a book on the subject, Messages from Water, and it captured a huge audience and sold so many. And by the way, another version 20 years later just came out a year ago. I actually wrote a foreword to the book. And so with this kind of evidence, it looked like information coming from Emoto himself, and some kind of subtle information that nobody could really understand. He was able to create an impact. Apparently, the information that came from his mind, from his thinking, or in some cases playing music, playing Mozart symphony, gave lovely ice crystals, but other kinds of modern music, kinds of rock music did not. So the problem with him, and why he's roundly criticized justifiably by scientists, is he didn't do it exactly the way I described. He had 50 petri dishes. He'd fill them with water. He'd put his attention to all 50 petri dishes. He'd freeze them and then look, and he'd pick out the one of the 50 that demonstrated what he wanted to demonstrate clearly. And it's not the way a scientist would do it. Scientists would choose randomly. So for that reason, most scientists will just dismiss out of hand anything that comes from that laboratory. But there are other people now who are doing experiments where they test repeatability, and they're coming out with positive results, and people will hear about that. So this is sort of from the spiritual end. And there are many scientists, many of whom come to our conference. I organize each year the annual conference on the physics, chemistry, and biology of water. And at the other end, at the scientific end, there are many scientists who come and report at our conference, usually 2 or 3 each year. And I don't want to go into every experiment because that will take too long, but the culmination of all this is a series of experiments by a person who I guess many would consider distinguished, well recognized. He won a Nobel Prize, and that's the late Luc Montagnier. And what Montagnier demonstrated scientifically, and now confirmed by a few groups, is let me just tell you his experiment briefly. So he puts DNA in a buffer of some sort, in a container, and the container is sealed. Nothing can get out. It's factory sealed container containing some short strand of DNA. And next to it, he puts another container that contains only pure water, again, factory sealed, so that there's no way that any of the contents of any of these can get out to cause a contamination. And he imparts some generic kind of energy, like 50 hertz or 60 hertz. So the two of them basically are sitting next to each other for a day. He hypothesizes that the information from the sequence of the DNA is somehow being transmitted to the water through some subtle energies that he doesn't understand and nobody understands. So then he takes throw this away, takes the water, and he combines the water with the chemicals that are part of the now famous PCR reaction to create new DNA and create lots of the new DNA. And he compares the DNA that had sat next to it with the new DNA, and they match, which means, wow is right, which means that his hypothesis is supported, that somehow through some kind of subtle energy between the original DNA or the water that surrounds the DNA, he actually thinks or thought that that was more likely because he could dilute the DNA hugely, leaving essentially only the water that had been in contact with it. And that gave the same result. So the water that had been in contact with the DNA could now impart energy to the water. So the bottom line is there's been a long line of experimentation. You might say starting, but actually there's earlier stuff, starting with the spiritualists and now coming to the scientists, all of which are suggesting that there's some kind of information that's imparted. And I've given you a couple of examples of the kind of information. It's all vague. Nobody even can hypothesize the nature of this subtle information, and nobody understands exactly how it's imparted to the water. I'll just say one more thing. I think it's not liquid water. I think it's easy water, because liquid water, the molecules are randomly oriented and they're bouncing around a fierce number of times per second. And it's hard to imagine that information could be stored in that a liquid of that nature. But easy water is different because it's like a crystal, a liquid crystal. And liquid crystals, or crystals, I should say, are what are used in today's computer memories. You have an array of transistors and they're silicon crystals, basically. So a possibility is that those crystals, transistors, an array of transistors might one day be replaced by easy water. Mm-hmm. The theoretical information density is 9 orders of magnitude higher, because we're now dealing at the atomic level instead of the supramolecular level. And the hydrogens and oxygens are, as I said, at the atomic level. So in years from now, it could be that easy water, which, by the way, can now be produced in solid form at room temperature, as discovered by an Italian group, and we've recently confirmed it.
Wow.
So yeah, that I hope that answers that question for you. I'm happy to go further with you, but I think we have limited time.
Yeah, and then maybe one more tip regarding health, and we'll finish there.
Pay attention to all of the potentially destructive impacts of what people have been talking about. I think they're real. For just one example is glyphosate, which is in Roundup, a weed killer. And the presumption is, well, it kills the weeds, but it has no impact on us. And the work, many works, as compiled by Stephanie Seneff from MIT, suggest the opposite. And we actually did experiments with glyphosate, and we found, unlike the Ayurvedic type agents which built easy water, glyphosate diminished easy water at every concentration. And so it basically dehydrates, and it might kill by dehydration. And the evidence that has been produced by so many groups and compiled by Stephanie Seneff suggests that this could be a problem. And so I guess you're asking for advice, and I would stay away from anything as much as you can that contains glyphosate. It's not good for your health.
This is very, I think, a fascinating note to end on, because it paints a sort of paradigm of one potentially key mechanism of human health is this sort of battleground to maintain the appropriate state phase of water and charge of water in our cells. And we can conceptualize the degree to which we are engaging in practices that are building that easy water in our cells, or the degree to which we are engaging in things which are diminishing
Absolutely.
it. And
Absolutely.
so, to what extent are you getting outdoors and getting sunlight and walking on the earth and doing saunas and cold exposure, and perhaps drinking, consuming lots of vegetables or drinking vegetable juice, versus taking in pest, and I should also mention sources of Ayurvedic herbs, turmeric and holy basil, and some of these other compounds that are easy water building, versus to what extent you're in indoor environments, you're in an infrared deficient environment, you are not getting adequate sunlight, you're taking in, or you're consuming or otherwise being exposed to chemical substances which are diminishing this easy water. It kind of creates this interesting battleground for, which side of the scale is being tipped more, and therefore what's the state of the easy water in your cells.
Oh, so well put. I couldn't add another word to that.
Beautiful. Well, we'll end there. Thank you so much, Jerry. It was really a pleasure and an honor to connect with you. It's just something I've wanted to do for many years now. And tell us again where people can donate to your lab to help fund your further research.
The lab website, which is kind of fun to look at anyway, it's pollacklab.org, pollacklab.org, or my email address, ghp@uw.edu, ghp@uw.edu. And if you lose that, it's all over the internet. I'm not invisible.
Thank you so much. Oh,
thank you.
Thank you so much, Jerry. It was really an honor.
Yeah, great pleasure. Thank you so much.
I look forward to next time.
Okay, take care.
Hey there, this is Ari again. Thank you so much for listening to this episode. I hope you enjoyed it. If you did, if you found it valuable, please share it with your friends, share it with your family, help me get the word out there. Also, if you're on YouTube, make sure to hit the subscribe button and hit that little bell to get notifications every time we release a new video or new episode of the podcast. And if you're listening to this, make sure to subscribe to this podcast on iTunes or on your favorite podcast app. Thanks so much for supporting my work at the Energy Blueprint. I hope you enjoyed this episode. I will see you in the next